everyone. Today we are going to talk, or rather we are going to start element 3. And element 3 is about basics of fire prevention and protection. Now this element, again, you have to understand that what course or whatever the series that is going on. So in this, we covered last time the statutory requirements, and this time we will be covering basics of fire prevention and protection. So let us try and understand that what this element 3 is actually consisting of. As you all know that this is part of the entire course that we have, but the course that we have developed. But yes, what we are taking here in YouTube, these are short videos. So today we will be discussing on fire explosion hazards. But if you want to understand that what element 3 covers in basic fire prevention and protection, so it basically covers fire explosion and hazard. It covers chemistry and classification of fire, principles of extinguishment, then portable fire extinguishing system, you have portable fire fighting system, and then last but not the least, the fifth element, and that is fixed fire fighting system. So these are the 5 core points that are covered under element 3. And when why we are discussing these elements individually is because we wanted to give a clear picture that what exactly is the element all about. Now let us start with the basics of fire prevention and protection, and today we'll be discussing the first topic. So before starting the first topic, we must understand that fire explosion hazards. Everybody is aware of what explosion hazard is all about. Okay, when fire happens, explosion happens. All right. But when it comes to fire explosion hazard, we must understand, or rather know a certain definitions that should always be in our back of our minds, so that we have a better understanding of the subject element. Now, definitions are very important. Naturally, if you don't know the definition, then how you will be able to explain things? How you will be able to explain that what is what is what? Correct? And the reason behind explaining these definitions is this only, that every aspect of the studies involve certain definitions which cannot be changed. It is not my perception, it is not your perception, it is the standard that is defined across the years, throughout the years. So many years of research and everything has gone, and then some theories or some definitions have been derived. So let us understand the definition, a term connected with fire and explosion. So the very first term is flammability characteristics. So flammability of a liquid varies at the rate at which it vaporizes, and it greatly depends on the vapor pressure. So vaporization increases with the rise in temperature, and a flammable liquid at an elevated temperature is more hazardous than the same liquid at normal temperature. So you need to understand the flammability characteristics. So flammability of a liquid, you have to understand that any liquid at a higher temperature is more hazardous than the same liquid at a normal temperature. So the combustion of a flammable gas or air mixture occurs if the composition of the mixture lies in the flammable range, and if the condition exists for ignition, which is caused either by bulk gas temperature or by local ignition. So you have to understand, see, what are the characteristics of any liquid. Wherever there is liquid, if the liquid vaporizes, so it causes gas form. So now this gas form is basically, if at higher temperature, it will definitely have a ignition point which is far more lower than the actual liquid's flammable point. So this is why flammable characteristics, you have to realize that any form, may it be liquid or solid or any gas form, with high increasing temperature, the hazard also increases. This is the reason why, wherever the stores are there they say that you need to have good ventilation so that the temperature remains at a lower level. Now the second definition that you must know is flammability limits. A flammable gas burns in air within a limited range of composition, correct? So the lower flammability limit is such that below this limit mixture is too lean to burn, and also is called as lower explosive limit, that is LEL. So what do you say? A flammable gas burns in air with a limited range of composition, correct? So if how much percentage of gas is present in the air, that decides what is going to be the whether it will be explosive, whether it will burn or not, right? So the lower flammable limit is such that below the limit mixture is too lean to burn, correct? So it will not burn. So that is called lower explosive limit. While above certain concentration, upper flammable limit, it is too rich, is also called as upper explosive limit, that is UEL, correct? So the definitions and the terms you must understand. So what is UEL, what is LEL? So these are the two terms that are normally used when we are talking about the fire and explosion. So I'll again explain the UEL. While when we explained lower explosive limit, then while above the certain concentration, when the concentration of gas increases, the upper flammability limit, it is too rich and is also called upper explosive limit. The concentration between these limit constitutes to the flammable range. So flammable limits are affected by pressure, temperature, direction of flame propagation, gravitational field and surrounding. So flammable limits are affected by pressure, temperature, direction and flame propagation, gravitational field and surrounding. So decrease in pressure below atmospheric can narrow the flammable range by rising the LEL and reducing the UFL, that is upper flammable limit, until the two limits collides with the mixture becomes non-flammable. Conversely, an increase in pressure above atmospheric can widen the flammable range. The flammability limit are also affected by addition of an inert gas such as nitrogen, carbon dioxide or steam. In general, carbon dioxide causes a great narrowing of the flammable range, and then does the nitrogen. Here you have to understand, carbon dioxide causes greater narrowing of the flammable range than does the nitrogen. Now there are also flammable limits for combustion of pure oxygen. In general, the lower flammable limit of a gas is almost the same in oxygen in air, but the upper flammability limit is much greater in oxygen than in air. The flammability range in oxygen is thus wider than it is in air. There are also flammability limits for substances which burn in chlorine. So you have to clearly, this I am just giving a brief idea about flammable limits. Now the third point comes to as ignition temperature. If the temperature of the flammable gas air mixture is raised in a uniformly heated apparatus, it eventually reaches a value at which combustion occurs in the bulk gas. Flammable mixtures has lowest ignition temperature, which is known as minimum spontaneous ignition temperature or auto ignition temperature. Some substances have quite low auto ignition temperature like carbon disulfide at 90 degrees Celsius. The auto ignition temperature may be reduced by as much as 100 to 200 degrees Celsius for surfaces which are lagging or contained by dust. So ignition temperature. So how do you explain an ignition temperature? So explaining ignition temperature, see these were the definitional part. Now you have to understand what are the ignition temperatures. So ignition temperature, it is very simple. Any temperature at which anything or any area or any material, any fuel starts burning. So that's the ignition temperature. So there are different chemicals that have, at different conditions. Now you cannot rely on fuel, just fuel. So fuel at a liquid state might have an auto ignition temperature at a lower, at a higher level. But again, the same when that liquid is converted into fumes, the ignition temperature goes down. So that's the reason why, when you have nothing was there, how fire happened. So there are these terms. Ignition temperature play a very crucial role there. Now coming to the flash point. So flash point of a flammable liquid is a temperature at which vapor pressure of the substance is such as to give concentration of vapor in the air, which corresponds to the lower flammable limit. There are two methods of measuring flash points: the closed cup test and the open cup test. The open cup flash point is usually a few degrees higher than the closed cup flash point. A liquid which has a flash point below the ambient temperature and can thus give rise to the flammable mixture under ambient condition is generally considered as more hazardous than on the higher flash point. So what are the flash points? So we explained auto ignition temperature. So auto ignition temperature is like a temperature which is abnormally rising, because of which the ignition happens. But here when we talk of flash points, so there are two methods. There are open cup and closed cup. So what happens if you have placed any material which cannot be stored at an ambient temperature, so it requires cooling. And if a temperature that no matter, even if it is stored in open area, but it cannot take certain level of temperature, then it goes to flash. So that again auto ignites. So flash point and these are more or less similar, but yes, the flash point of a liquid, vapor, whenever any liquid forms a vapor form, then it becomes more hazardous. So this is the basics of fire, wherein you need to understand the ignition temperature and flash points. So flash point means instantaneous higher flashes, immediate burns. Now coming to the next part of it, and that is fire point. So fire point of a flammable liquid is the lowest temperature at which liquid, when placed in the open container, will give off significant vapor to continue to burn when once ignited. The fire point is usually a few degrees above the open cup flash point. Ignition energy. So ignition of a flammable gas air mixture by a local source of ignition by electrical discharge occurs only if the later possesses a certain minimum energy. The minimum energy usually occurs close to the close to the mixture, or you call it as stoichiometric mixture, something like that. So that's what it's all about. Whenever you are placing any it is not that the electrical spark is happening somewhere and the fumes are generating somewhere. So it has to happen very closely. Only then ignition energy will happen. Vapor pressure. So vapor pressure is exerted by a gas or vapor in all direction in a closed container at a given temperature. The vapor pressure of a liquid at any given temperature which the vapor and the liquid phase or the substance are at equilibrium in a closed container. Relative rate of evaporation of the liquid are indicated by vapor pressure. The higher vapor indicates high rate of evaporation. The percentage of vapor in the direction is direct, in direct relation between the vapor pressure of the liquid and the pressure of air. Now coming to vapor density. So density of a petroleum vapor or gas is greater than the air, correct? It is heavier than the air and tends to remain in the ground level. It in pits or flow and flows at a long distance through drain and trenches. Once ignited, it will travel back to the source of release, that is flashback, and petrol vapor about 3 to 4 times heavier than air. So you have to understand, petrol vapors is about 3 to 4 times heavier than air, and it can settle in low areas, ditches and drains, and travel long distance to cause ignition and flashback. So whenever we are saying that how it happened, so this is how things happen or things messes. So you have to understand the vapor density of each liquid stored in your premises so that adequate provisions can be made, and you have to understand its characteristics, that yes, this travels below, this travels above, like that, correct? Now coming to boiling point. The lower the boiling point, the substance is more volatile and consequently more hazardous, such as a flammable liquid. A boiling point decreases, the vapor pressure and evaporation rate increases. As the boiling point decreases, vapor pressure and evaporation rate increases. Now viscosity. So viscous liquid spreads slowly. Viscous means how thick the liquid is. So viscous liquid spreads slowly. When released, a fire in them generally burns slowly in a smaller area than the equal volume of liquid which is less viscous and flows freely, correct? However, viscous oil sprayed in a mist form with 10 micron size evaporate faster and behaves like a vapor. So if you have a viscous oil, like you have grease spray, if something is done, so it vaporizes faster, and when it vaporizes faster, it is again more dangerous, because it will act similarly as its counter liquid part. In tank, viscous liquid layer contains containing small quantity of water by heat conduction boils to form steam, expanding to 1700 times 2 liters water volume. This causes boil over of liquid, forcing the liquid under violent force. In case of large tanks, the burning oil can cover a wide area. Now coming to one more important definition, and that is kindling temperature. So this temperature, this is a term used to express the temperature of which a solid matter such as paper, wood must be raised to begin burning. So this is what overall definitions are all about. Now let us try and understand the general classification of hazardous area and safety aspects, including flame-proof electrical equipment. So you have to understand, this video is going too long, but I'll take it very quickly because there is not much of the much things in here. We have already explained the definition, so now things will be much clearer. Now coming to the very first point in general classification of hazardous area, that is HAC, that is hazard area classification. So the classification of area for electrical installation in petroleum refineries and other similar areas which deals in with hazardous chemicals and hazardous material, they need to classify the area. So these hazardous areas where have high risk of explosion due to gas and vapor existing in the area, and which flammable gases and volatile liquids are processed and stored or loaded or unloaded or are otherwise handled. So the classification has been done according to the extent of risk involved so that it provides a guide. It provides a guide to choose the equipment to be installed in different areas on the basis of extent of hazard. To determine the type of electrical installation uh, appropriate to a particular situation, the area has been divided into three main divisions. Correct? So it was, you can say, three main divisions or three zones. So now these three divisions were division 0 or zone 0, zone 1, zone 2, division 0, division 1, division 2, according to the degree of probability of presence of hazardous atmosphere. So what is division 0 area, zone 0, you can say? So it is an area in which hazardous atmosphere is continuously present. That means it is always present there and shall fall under the category since the hazardous atmosphere exists continuously. Any failure of electrical apparatus installed in this division 0 or zone 0 area would almost certainly lead to fire or explosion or both. Therefore, any installed electrical apparatus must afford to the degree of protection as near as practicable to the absolute. It is recommended that the use of electrical apparatus should, where practicable, be completely excluded by division 0 area or zone 0, but when this is not practicable, the recommendation laid down in IS 5571, that is Guide for Selection of Electrical Equipment for Hazardous Area, should be followed. So you must understand that why I'm giving you the IS code. So it is IS 5571. So 5571 is the guide that gives you clear picture of which type of electrical equipment to be used in this particular area. Now you have to understand zone 0 or zone division 0 area is the area where vapors are continuously present. So when any vapor or any hazardous material is present in that area, so naturally you need to work on that. You need to ensure that any electrical should be very safe. It should be not only intrinsically safe, but it should be as per the selection criteria of IS 5571. Now division 1 or zone 1 area, what is that? An area in which a hazardous atmosphere is likely to occur under normal operating condition shall fall under this category. So under normal operations, like you are opening the reactor vessel, so that is normal condition. So this classification is applied to area in which hazardous atmosphere is likely to occur at any time and which therefore requires the fullest practicable applicable measure to prevent the occurrence of hazardous electrical condition at any time and in any circumstance. Recommended type of electrical apparatus are and wiring for use in zone 1 or division 1 area is given under IS 5571. You can refer that. Now division 2 area, in the area, an area in which hazardous atmosphere is likely to occur only under abnormal operating condition. So you have to understand, in first zone 0 condition, it is always there. In zone 1 condition or division 1 condition, it is there, but it can occur in normal operation. So in normal operation it can occur. But in division 2 area is the area where only in abnormal condition it will happen. Correct? So this classification is applicable only where fire and explosion hazard is likely and may be caused only by simultaneously or improvable occurrence of arc or spark resulting from the electrical failure and a hazardous atmosphere arising through the failure of the condition of control. It presupposes that any hazardous atmosphere resulting from the abnormal occurrence is rapidly suppressed, and any situation which allows the hazardous atmosphere to collect, such as a pit, trench, although it may be in open area, shall be itself classified as division 1, and even though the surrounding area is classified as division 2. So you have to understand all your ditches, bridges, or wherever you're collecting, are the collection pits. So there also the classification is zone 2, where the material is not present, but it is classified under it because in case of abnormal condition, the material is going to come there. So that also comes under zone 1. So all the electrical fitting and everything has to happen as per zone 1. So it should be as per IS 5571. Now what is safe area? So although generally speaking the safe area may be ascertained without difficulty, the following examples, very very easy examples are there. Enclosed premises in which any compressed atmosphere is there, which can cause ignitions or something like that. So that comes, we are explaining safe area. Okay, so when any not an imminent or immediate danger is available, so there are some containments that are made, enclosed premises are made, so which actually by purging of steam or safe atmosphere is continuously maintained, so that no opening therein may be a point of egress of gases or vapor coming from the external source can be considered there. So any hazard should be classified as safe. So what we are doing is that we are actually enclosing, when we are enclosing the hazardous area, and when we are closing it and we are containing it inside, and we are purging the gases, and we are trying to make it safe. So that's what safe area is all about. Piping carrying petroleum and petroleum products laid in the open outside the hazardous area should be classified as safe. So standards say that if there are containers, if you are storing the petrol in a tank, that's unsafe. But when you're transferring it through a pipeline, it's safe. So the safe area is that. So that's how it is defined. Now, safety of a flame-proof equipment. So flame-proof apparatus is achieved by fitting the electrical equipment into an appropriate flame-proof enclosure designed in such a way that it is that if a flammable vapor enters and is ignited by a spark, the flame and the product of the combustion are contained by the enclosure and do not ignite an external flammable atmosphere. The enclosure must also have significant strength to contain the pressure of the internal explosion. So this is what flame proof is all about. So what is flame proof? So when we say that flame proof enclosure is there. So flame proof enclosure means it can contain whatever will happen inside. So that's the definition of it. Now, health hazard due to fire explosion. So the main threat of fire and gases, that is heat oxygen deficiency. The temperature in a room in a house can easily reach to 500 to 1000 degrees Celsius. As many as 400 toxic compounds can be demonstrated in a smoke. The principal toxic constituents of smoke are soot, carbon monoxide, carbon dioxide, nitrogen oxide, hydrogen chloride, sulfur dioxide, hydrogen fluoride, hydrogen sulfide, isocyanide, acrolein, benzene phenol, formaldehyde, and range of chlorinated hydrocarbons. So carbon monoxide is an important factor, that is 50 to 80% of the of our all fire fatalities. So even if not directly fatal themselves, carbon monoxide and hydrogen cyanide singly or in combination may lead to a rapid encapsulation of the individual, who can then will be unable to escape. So basically what happens is that when we talk of health hazard due to fire explosion, so whenever there is an explosion, there are multiple number of gases that are present there. So what happens if any any of these gases, the percentage increases, so it causes, choking. It causes our lungs to non-function, so we'll not be able to breathe. When we'll not be able to breathe, so we'll not be able to escape. When we'll not be able to escape, then we'll be facing fatalities. So this is what overall purpose is of understanding the health hazard due to fire explosion. And you have to understand that whenever there is fire, so material is burning. Now that material, whatever material is burning, it has its own impact and implications. Correct. Now, first aid measures. Now, I believe that everybody is aware of the first aid measure. Regardless of the kind of gas involved, the victim should be moved immediately to fresh air. They might lead to, the cardiac arrest should be there. So you must know CPR. And then whenever you are approaching any individual who is burning, you have to approach it from front, grab him, don't let him run here and there, don't pound him. And this is the basic first aid that everybody is aware of. So I hope you have liked the video till now, and I was able to contribute as much on this particular topic, because these are again very boring topics, because they are all legal part and the legal aspects or the definition parts. But yes, understanding these topics is very important, because these actually forms the basics. So when we are going to discuss chemistry of classification of fire or principle of fire extinguisher, portable and fixed fire fighting system, so then all these things, if you are not aware, so you'll not be able to give the right kind of justice to it. So I hope you like the video and keep liking and sharing, and I hope we were able to contribute much. And do not forget to hit the bell icon so that you get notifications of whatever videos we post next. Thank you so much.